In this video, I'm going to make a battery with copper and permanganate. Why do I do that? Because I want you to realize if you have aqueous and aqueous, you can have an inert electrode. So as a practice, I'm doing that. First thing I need to decide is which element goes through oxidation. You cannot have two gain of electrons or two reductions. So the first element above, I'm going to reverse the reaction, because that will give me a sum of positive voltage. So copper is going from solid, in this case, to aqueous. The voltage will be negative, and it's still oxidation. Permanganate is as is, except you also need to make sure electrons are equal to each other. You cannot gain 5 and lose 2. So plus 4H2O, and this is positive 1.53. Now what I'm going to do before sum it up, I'm going to multiply equation above by 5 and equation below by 2. That gives me 10 electrons being lost and 10 electrons gained. One other thing you should realize and be careful of, never multiply your voltage. That's intensive. It's not important whether you have 5 or 10,000 of those species. So sum of the reaction is you have 5 copper solid plus 2 potassium permanganate. Now potassium is spectator ion, we don't have to write it, plus 16H plus, which comes from hydrochloric acid, nitric acid, because it's acidic redox. 2 copper ions come to life on the product side, plus 5 rather. 2 Mn2 plus, this could be Mn chloride or manganese sulfate, plus 8H2O. Your cell is addition of 1.53 to negative 0.34. I think it is positive 1.19 volt. Since it's positive, it's spontaneous. Last thing to do is make your battery. So we have 2 beakers next to each other. In one of them, I'm going to put copper, solid, and it's sitting inside solution of Cu2 plus. In the other one, since they're both aqueous, I have no choice but use an inert electrode. I'm going to use platinum, solid. Now inside this beaker, you have combination of MnO4 minus, you have Mn2 plus, you also have your acid because it's acidic redox. So the reaction is almost ready to take place. Connect via external copper wire and a voltmeter. Not yet, you need a salt bridge, so let's put our salt bridge. Now this salt bridge, this time I'm going to use potassium nitrate. And let's see what happens to those ions. How do they compensate? On your inside your anode, because this is oxidation, inside your anode you're producing a bunch of copper 2 plus. So what happens is your nitrate is going to go into that solution. So nitrate is coming down into this solution to compensate for the positive ions. And inside your cathode, you're using MnO4, which in this case Mn is positive 7 becoming positive 2. So you need to produce more positive. So potassium ions are going into this. So anions go to anode, cations go to cathode in case if you're being challenged. Then again, we decided copper is anode because you lose electrons. Electrons get accumulated on this negative ion electrode. This is your cathode and should be positive. Electrons always move from anode to cathode, so also lay out that direction and your battery is good to go. You might be challenged which one is losing mass, which is case of copper because it goes from solid to aqueous.